Hey maths fans, looking at ln, the natural logarithm. The reason it's ln is because in Latin it's logarithmus naturale, or something along those lines. So that's why it's ln, natural logarithm, logarithmus naturale. So basically this is logarithm which has the mathematical number e as its base. Now, hopefully you've had a little look and seen what E is. It's roughly 2.718, something like that. So all we're doing is we're taking a very particular base for a logarithm. And because we use it and it's so useful in maths, it's instead of writing this log base ex, we write ln x. Logarithmus naturale x. Okay, that's all it is. It's a logarithm with this strange mathematical number e as its base, the irrational number e. Okay, let's see what we can do with it. Let's say we had this. We want to know e to the power of something equals 250. Well, what we can do is we can use that natural logarithm, that ln, and we take the natural logarithm of both sides, ln of both sides, and that will tell us what x equals. So x will equal ln 250. It's worth noting here that the kind of ln e sort of cancels out. If you're finding the logarithm with the same base as the number you're doing to the power of, they kind of cancel out. So ln e always cancels out. And if we show how we work that out on a calculator, I've just gone in my menu here to number 1, and we're going to say ln, that button in the middle there, 250, and it's as easy as that. And it gives us this answer, 5.5214 something. So we get x is roughly 5.52146. And it's worth being able to check that as well. So if you want to check that, and check that e to the power of something equals 250, we'll put this number in for x. So let's just check our answer, make sure that we're comfortable with both parts, the e to the power of and the natural logarithm. So I'll go shift on the same button as the ln. Above that we get this e to the power of x. So I'll put 5.52146, and let's see what that comes out as. And you can see I get 249.999. Because this isn't fully accurate, this is not, this is a rounded value, we get very, very close to 250. So I can be pretty comfortable with that answer. So that's kind of the basics of it. ln is just the natural logarithm. It is logarithm with base e. So it's like saying, what do I do e to the power of, or e to the power of what gives me 250? And to find out, we use the ln. Let's look at some other stuff we can do with it. So if we wanted to use our calculator to write this number in the form e to the power of k, correct to 4 decimal places. Well, it's important that you understand the natural logarithm, otherwise you wouldn't be able to do this question. You're not just going to be asked, type this in a calculator. You need to understand the question first, and then use your calculator efficiently. So here, what we've got is very similar to that last one. And so when I set that up, I can say, oh, okay, now I need to take ln of both sides. So ln of e to the power of k. And so k is going to equal ln 0.005. So we would type that in our calculator again, and we'll go ln 0.005, and we get minus 5.298. Wait, 4 decimal places, minus 5.2983. Minus 5.2983. So that's how we can use it to answer a kind of one exam style question. Let's get into some more complicated stuff in a second. Here are the 2 very important facts we should note. make a note of this. If you're just watching this passively, get a pen and pencil out. Well, in fact, you don't need both. You can have either, a pen or a pencil. You're going to need paper though. And make a note of this. Anytime that we've got ln e to the power of x, if I'm finding the natural logarithm of e to the power of x, well, I'm finding what x equals. So these kind of cancel out. Same the other way around. If I've got e to the power of ln x, it's just x. Okay? So just make a note of those two formulas there, or those two key points. Very useful to be able to spot that these things, we get x. These things, we get x. Okay? On we go. Let's look at some examples of how we might apply that. So if I've got ln e to the power of 6, well, that's saying e to the power of what is e to the power of 6? Well, it's 6. These things cancel out. If I'm doing the natural logarithm of e to the power of something, it's just the something. Here we're going to need the second one here, we're going to need to know a little bit more about indices. I know that 1 over e to the power of 5, that is the same as e to the power of negative 5. You need to be comfortable with your negative indices. So if I write this out as ln of e to the power of negative 5, you can see I've got that same thing, cancel the ln and the e, and so I get negative 5. Then the last one, we are going to need a little bit more knowledge of indices. So I know that if I've got 3 times ln 4, well, when I'm using a power to a power, I multiply the powers. So here I've got multiplication of powers, so I could rewrite this as e to the power of ln 4 all to the power of 3. The reason I'd want to do that is because, oh look, these cancel out and I end up with just 4 to the power of 3, and 4 times 4 times 4 is 64. So there's 3 examples of some more complicated things that you might have to look out for. But the key notes there are anything where you can get e to the power of ln something, you can cancel them, and ln e to the power of x, we can cancel the ln e. Right, I hope that's made some sense.